Hey guys, so today we're going to talk about linear inequalities. You're going to be able to solve and graph linear inequalities. So first, we have to talk about what each of these symbols mean. When we are reading inequalities, we read from left to right. So when we're reading these signs, this first sign is greater than. The next sign is less than. The third sign is greater than or equal to. So that bar underneath the greater than sign means or equal to. Greater and the last one is less than or equal to for the same reason. The or equal to is when we are going to include the value that it's equal to in our solution set. So that also comes to when we are graphing on a number line. We graph using points. If we have an open circle on a point, that means that number is not included in our solution set. But if we have a filled-in circle, that means that that number is included in our solution set. So this is not included, and this one is included. Then when we are graphing, if we have a dotted line, that means that value is not included once again. And if we have a solid line, that means it is included. Now let's look at some inequalities. We treat inequalities just like we treat equations. So when we are solving for x, we're going to use the same steps. I'm going to add 1 to both sides of my inequality and get 3x is less than 6. I then am going to divide by 3 on both sides and get x is equal, I'm lying, x is less than 2. We bring down that inequality sign. X is less than 2 is our solution set. So I'm going to go to 2 on my number line. I am making an open circle because there is not an or equal to, so 2 is not included in our solution. And I am shading to the left with an arrow because I want the values that are less than 2. So I'm going towards the negatives. So if there's one variable we graph on a number line, unless we are using coordinate planes and finding the solving a system of inequalities, and we'll get to that later. So for right now, if you have one variable, graph on a number line. If we have 2 variables, we're going to graph on a coordinate plane. Using this inequality, we're going to transform it into y equals mx plus b, or slope-intercept form. So I want to move over that 2x first. Get 2x is greater than negative 2x plus 6. Divide by 2 on both sides. Y is greater than negative 1x plus 3. So now I know my y-intercept is 3. So I'm going to plot that point. And my slope is negative 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. I'm going to connect these with a dotted line because I do not have my or equals to. So I'm going to connect the up connecting these with a dotted line. And the last part of graphing an inequality is to shade. So where would the greater values be? Above or below this line? Well, if I pick a value down here, say 0, 0, and plug it in, is 0 is 0 greater than -1 times 0 plus 3? 0 is greater than plus 3? No. So, I picked a test point down here. It didn't work. So that means up here is where my solution is. And we shade it in. And that's all for the first part of linear inequalities.